In this lesson, we're going to be talking about naming, specifically ionic naming. So when we do this, we start by writing the cation first, followed by the anion. We determine the charge of each ion, and finally we determine the ratio of cations to anions needed to make the compound neutral. So let's look at this example. So we have potassium, which is our cation, and we have chlorine, which is our anion. Potassium has a positive 1 charge, and chlorine has a negative 1 charge. So this is pretty straightforward. We just have our 1 potassium followed by our 1 chlorine. So let's look at this one here. It says, write the ionic formula for sodium and oxygen. So sodium is going to be our cation. So if we look here, sodium has a charge of positive 1. It's a group 1 element. And oxygen has a charge of -2. Oxygen has 6 valence electrons, so it wants to pick up 2. So when we write out our formula, we know that we have sodium, of course. However, we need 2 sodiums to balance out with the 1 oxygen. Okay, so sodium again has a charge of +1. Oxygen has a charge of -2. So to get these to balance out, we're taking 2 times the +1, and then we're subtracting the -2. So this is like thinking of it as +2 minus 2 gives us 0. Okay, let's look at another example. In this example, it says write the ionic formula for calcium and iodine. So calcium is going to be our cation. Calcium has a positive 2 charge. And we've got iodine, which has a negative 1 charge. So when we go to combine these, calcium has a positive 2 charge. Again, we write the cation first. Iodine has a negative 1. So like in the last example, we need to add a 2 here because our negative 1 needs to cancel out with the positive 2, and the only way to do that is to multiply it by 2. So again, think of this like positive 2 minus 2 times negative 1, and that gives us 0. We want to have a 0 net charge. If we don't have a 0 net charge, we made a mistake. Let's look at the next one. All right, let's look at this example. We have aluminum and bromine. Aluminum is our cation. It has a positive 3 charge. Bromine is our anion. It has a -1 charge. So when we go to combine these, to counter our positive 3 on aluminum, we're going to need 3 bromines. And think of this again like we have a positive 3, and we need to subtract off the 3 -1 charges. So this is going to give us a 0 net charge. All right, one last one. Let's look at barium and phosphorus. This one's a little trickier. So barium has a positive 2 charge. Phosphorus has a -3 charge. All right, now, if you look at these two numbers, we want to get these to cancel out. We want to find the least common multiple here. So the least common multiple of 2 and 3 is going to be 6. So to get to 6 from 2, I have to multiply by 3. To get to 6 from -3, I have to multiply by 2. So this is going to be Ba 3 P 2. So we have 3 bariums and 2 phosphoruses. And just like before, just to prove the math here, we have 3 times 2, and we're going to subtract off 2, and then -3. So this is going to give us a net charge of 0. So let's talk about how we go the other way when we have the formula rather, and we want to write out the name. So just like before, we're going to write out the cation first, followed by the anion. Same step as before. We never change the name of the cation. Again, it's just write it out. Now for the anion, we drop the ending and add the suffix IDE. So in this example down at the bottom, we have sodium, and we leave sodium just like it is. And then for the anion, we have sulfur. So instead of writing out sulfur as SULFUR, we take the ending here and we replace it with IDE, just like we did here. So let's look at this example. We have Mg and Cl2. So we have magnesium. Our first step is to just write out the cation. And the anion is chlorine, but we're going to replace the ending with IDE. So this is going to become chloride. And even though we have a 2 here, that doesn't change anything. It's still chloride. Here's our next example. We have potassium. And our anion is oxygen. We're going to change the ending. So instead of oxygen, it's going to be oxide. For this third example, we have lithium. And instead of nitrogen, this is going to be nitride. Our final example here, we have Rb. This is rubidium. Oops. Just trying to be consistent with my coloring here. Rubidium, R-U-B-I-D-I-U-M. And the P rather is going to be phosphorus normally, but it's going to be phosphide here. So I provided everyone with a practice worksheet, and your homework was to complete that. Our exit ticket for today was CAF2. So our why can't I think right now? It's too late at night. I got to stop screencasting at night. This is going to be calcium. And instead of fluorine, this is going to be fluoride. F-L-O-U-R-I-D-E. Okay, and again, we've got that IDE every time on the anion. And that concludes this short lesson on ionic naming.